Bismillahirrahmanirrahim. In this part, I am going to add stud and bracing. So let's start this one. Click on this, and here first I have to define stud section. Add new property. I will use tube section. Stud, and this 150 by 100, and this one will be 5, and this one 5. I'll use 5, and this one get 36. For stud I can use a 36 KSI grade. Okay, and I will add bracing also. Add new property, steel circular. I'll use tension rod 25 millimeter dia, 25, and grade will be this one as we have defined before. Okay, now click on this, then go to stud section, and this moment release will be pinned here. Like this. Now I'll select the properties, frame section, stud, select, then I will replicate, pick 2 point from here to here, apply, and from here, sorry, this one, I'll show again. Select frame section, stud, select, then replicate, pick 2 point from here to here, apply, and we can PS means previous selection, this one, then we can do replicate, pick 2 point from here to here, apply. Okay, if we want to see the moment release, we can see, go to here, display option, here is the releases, frame releases. This is like this, this is our releases. We can draw now bracing, rod 25, like this. Then for roof bracing, if it is in the middle of this frame, then we can use that one. If it is not in middle, we can break this frame and we can create node, and we can snap that node to create bracing. For this tutorial I am considering at midpoint. This one is at midpoint. I'll copy this one. Here is the snap option, end and midpoint. So select this one, replicate, pick 2 point from here to midpoint, apply. Okay, now I will in the releases, and I'll draw the bracing like this, like this. In different also I can do. Now I can delete this one, and another way I will show. Like this, from here to midpoint, then this point, and then I will mirror this one. Go to edit, replicate, mirror, and here I will go for 3D plan, pick 3 point here, midpoint and this midpoint. Okay, apply. Now this is mirrored. Okay, now we will mirror these bracings also to other side. Go to replicate, mirror, parallel to shade axis, then pick 2 point, this and this, apply. Okay, so our bracing modeling finished. We can replicate or copy this bracings. Now I will show again releases. Okay, this this and this, or we can select directly from here, property rod 25 like this, then replicate, pick 2 point from here, middle of the frame, 1 2 3 1 2 3. That means from here to here I will add in the middle, then previous selection, pick 2 point from here to here. Okay, now this is our 3D portal frame modeling, and load already we have applied to our main wind resisting frames. Okay, now before that one, this bracing member I will make tension member only. Select the bracing, select assign frame tension and compression limit, include compression limit 0. That means it will not take any compression. Apply. Okay, now we will go for load combination. According to our design code, add default design load combination, it will be generated. First go for design, view reference, this AISC 36010, this is our design code, checklist for SAP. Okay, here we have finished all this loads, interior frame, tie member and modeling, assign bracing tension member, we have finished. And select the design code, ASC LRFD frame type IMF, intermediate moment resisting frame. This is a special moment resisting, I'll use intermediate moment frame, LRFD. Okay, other things, this here you can choose the limit, live load limit for deflection and other things. Okay, now for this bracing, as it is tension member only, so for bracing design we have to convert load combination into non-linear load combination. Go to load combination, add default design combination, steel frame design. Here this is our strength and deflection, limit state, choose load cases to use for limit state, here is your option. Okay, copy to deflection. Okay, yeah, so this is our load combination, 20 load combination generated according to our design code. We don't need to define any manual load combination. So, and this all load combination I have to convert into nonlinear cases to design the tension member only. Convert all the load cases. Okay, now go to okay. Now we will go to load combination. We will create a new combination 1. We will go to nonlinear and scale factor 1, add to for design of this bracing. Okay, add copy of this. We'll select the 2, modify. Okay, add copy, then go for dot combination 3, modify. Okay, add copy, then go for 4, modify. In this way we have to finish all the load combination. So we have finished the nonlinear load combinations. Okay, now click on OK. Now we will run the analysis. Click on this. You can see the analysis monitor option always show. Run now. So the analysis finished. We can see the analysis result. First we will see the deflected shape. This is for dead load, live shapes, collateral load, live load, Wx plus, Wx minus, Wy plus, Wy minus. So this is our deflected shape. We can check the frame result. Apply this Wx plus, Wy plus, and we can, this is axial force. We can see shear 2 live load. This one we can see moment 3 we can see in the YZ direction. This is our display process, and we can see in load combination also. Okay, now we can go for the final step, design. So click on this to design structure. So design finished. So it seems most of the frames have been passed. And here another thing, we can, here in checklist I have shown model purling to provide unbraced length effect or provide LTB value. We can provide an unbraced length ratio LTB value to the frames to get better result. Sometimes if we provide LTB ratio for purling, and in case of that LTB ratio providing, we must have to ensure the purling should be connected at the bottom flange also, with the bottom flange also with the stay angle. Purling will stay at top flange of the rafter, and it will be also connected with the bottom flange with a stay angle. Then we can apply this LTB ratio, otherwise we cannot. We can provide only for top flange. So in that case, in drawing we have to show stay angle connected with the purling and bottom flange of the rafter. So as it is passing without adding this LTB ratio. If you want to change this LTB ratio, I am showing that one. Because suppose for this frame you want to provide LTB ratio, if this is, I think this is 2.5 meter length, and here if the purling spacing is 1.44 we have considered, so 1.4 divided by the purling spacing divided by the frame length, the value will come. That value we will assign. Select this one, view device overrides, then here see the unbraced length ratio, these two, unbraced length ratio minor and this ratio LTB, these two we can change. For example, calculator 1 by 4 divided by 2.5.56 for this member, 2.5 meter member length. This is our 1.54 became 0.54 and 0.54. We can provide the LTV ratio. Now we can check the result display PM ratio, demand capacity ratio. For here I have provided LTV ratio, that's why it is 0.787 and this is 0.795. 787. Okay, this LTP is not governing here, that's why the result is okay. Here also 0.7877. For LTP, if it is failing, then after providing the LTP ratio, then member will have better result. If that LTP ratio is not governing, it is other factors are governing, then it will give the same result. So we can draw purling or we can provide LTP ratio in 3D model. The process of purling modeling I have shown in another tutorial in the SAP 2000 playlist. You can check there how to draw purling very easily. And if you don't want to model purling, you can provide LTP ratio. And this two member, as it is failing, I can change this two member, or I can change break this one, because this one will not have the full length. For example, I will divide this by half length. Divide into 2 frame, apply. Okay, so now we can run the analysis. Now design. So this two is failing, so we can change this section. This rafter section. Okay, define this in rafter, modify. We can choose this 0.3 web height, 300. Okay, done. Now we'll run the analysis. And we'll start design. It is also not passing. We'll check where it is failing. Details we'll see. Overstressed. Demand capacity ratio 1 by 4 PR by MR M3. This one MR MC22. Okay, then we will increase the thickness of flange. Then we will check interrupter, modify here, keep it 250, 5, this one 8, 8, and this one 8. Okay, now I will run the analysis. run design. So now it is passing. See, display design is for this is 0.916. DCR ratio below 1 means the member or frame is passed, because that is called DCR ratio, demand capacity ratio. Demand divided by capacity, the ratio demand is less than the capacity of the member, so it is passed. And our model is accurate for the load application, that's why see 0.916, here also 0.916. In other frames also it will be same 0.41, 0.579 in the reverse side, see 0.579, 0.411. So our load application is accurate, that's why it is showing this side and this side member DCR same. If our load application for wind load is by mistake or by any other reason wrong, then the opposite members will not have the same DCR value. So if that comes, then you have to check the model for load application. So this is our design course for 3D portal frame in SAP 2000. I hope you have understood all the steps and you have learned a lot of things from this tutorial. All of us, we have to improve our level day by day. We have to study the reference books, reference sources. We have to study in internet also. We have to uh, follow the research literature in very useful websites, so that we can develop ourselves day by day. And whatever I could do, I have tried my best to show the process and to explain the uh, design in explain the 3D portal frame design in SAP 2000. In the next course I will show this 3D portal frame design in STAT Pro. So stay tuned with my channel by subscribing and like my tutorials to inspire me, and share the tutorials with your friends and colleagues.
Press the bell icon on the YouTube app and never miss another update.